Hey everyone, today we're diving into a breakthrough that completely changed how computers get language. And you know what? It all came down to one super simple idea.
You've probably had this happen, right? You type something into a translation app and it just fails, or worse, it just spits the exact same word back at you. It's so frustrating, and it actually points to this really deep, fundamental problem in how machines used to read. Okay, look at this monster of a German word, Abwasserbehandlungsanlage. Now, for us, it's pretty clear this is a compound word, right? You can see the parts: sewage water, treatment, plant. But for an older translation model, if it hadn't seen this exact word before, it was just random letters. Total gibberish. The computer would have absolutely no clue what to do with it.
So here's our game plan. We're going to start with this unknown word problem, look at an old, kind of clunky fix they tried, and then get to the big aha moment, translating word pieces. After that, we'll meet the algorithm that made it all work, see if it actually held up, and finally, talk about how this one idea pretty much started a revolution.
All right, let's dive right in. First up, the unknown word problem. So here's the core issue. Language is, well, basically infinite, right? We're always making up new words, new names, slang, you name it. But the computers back then, they had a fixed dictionary. Imagine a real dictionary with maybe 30, 50,000 words in it. If a word wasn't on that specific list, the computer just hit a wall. It was what they called an out of vocabulary or unknown word. End of the line.
Okay, so what did they do about it? Well, the first attempt at a solution was this kind of workaround. It was called the dictionary backoff, and let's just say it wasn't the most elegant fix in the world. It was basically just a Band-Aid. If the main fancy model didn't know a word, it would back off and just look it up in a simple one-to-one dictionary. But, I mean, you can probably see the problems. This whole idea assumes every word in one language has a perfect single word match in another. That completely falls apart with compound words, like the German one we saw. And what about names? It would just copy the name as is, which is a total disaster if you're going from, say, the English alphabet to the Russian Cyrillic alphabet. It just doesn't work. But this is where things get really interesting. This is the aha moment. A group of researchers had an idea that was about to change, well, pretty much everything. And the idea itself was just so simple, it's brilliant. They asked, what if the computer doesn't need to know every single word? What if, instead of words, we taught it to translate the pieces of words, the little building blocks? And think about it, this approach is just so powerful. It works for names because you can translate the sounds piece by piece. It works for words that share roots across languages like claustrophobia. And most importantly, it totally cracks the code on those complex words with prefixes and suffixes. You know, the exact kind of thing that the old systems just choked on. So, for example, the model could learn that the English piece solar is a lot like the German piece Sonne, and system is like system. So by translating the parts, it can actually build the correct German word, Sonnensystem, on the fly, even if it's never ever seen that full word before. It's essentially creating new words from the pieces it already knows. Okay, so the idea is fantastic, but how do you actually teach a computer to find the right pieces? The answer, weirdly enough, came from a totally different field. It was an old-school data compression algorithm called byte pair encoding, or BPE for short. Yeah, BPO's original job was just to shrink files to save space. But these researchers had a clever idea. They adapted it to scan huge amounts of text and just find the most common strings of letters. The Lego analogy is perfect here. You know, instead of building with tiny single bricks every single time, BPO learns to find the common pre-built chunks, like ing or toin or re, because those show up over and over again. So here's the play-by-play. First, you take every word and just split it into individual letters. Then the algorithm scans everything and finds the pair of letters that appears together most often. Let's say it's E and S. It merges them into one new symbol, ES, and then it just does it again and again and again. Each time it finds the most common pair of symbols and merges them, slowly building up this whole vocabulary of useful word chunks. So look at the word low. It starts as just LOW. The algorithm might see that the L and O appear together a ton, so poof, it merges them into low. Then, a little later, it sees that the new low chunk and W appear together a lot, so it merges them into low. The amazing part is that it's figuring all this out completely on its own, just by looking at what's most common. Okay, the theory is really neat, it's elegant, but did it work? That's the real question, right? Did this actually make translations any better?
So they measured the overall quality using a metric called a blue score. All you need to know is it's a standard way of comparing a machine's translation to a really good human one. And yeah, the new Subword method got a better score. It was a clear, solid improvement, a definite win. But, and this is the crazy part, look at what happened when they tested it specifically on those unknown words, the problem we started with. The results were just wow. For English to Russian, the old way got it right about 6.5% of the time. The new BPE method, 18.3%. That's nearly a 300% improvement. This wasn't just a little better, it was a genuine breakthrough. And here's a real-world example that just nails it. The name Mirzaeva. To translate it into Russian, you have to change alphabets, transliterate it. The old system, it just copied the English letters, totally useless. But the BPE model, because it learned the relationships between the little pieces, it correctly spelled out the name in Cyrillic. It literally learned how to spell in another language. So you see, this wasn't just about making a slightly better translation app. This was a game changer, a fundamental shift in how we even think about building AI that understands language. The researchers themselves put it best. They basically said that by using these subword units, they had finally created a true open vocabulary system. The machine was finally free from its fixed dictionary. It could now, in theory, handle any word you threw at it. So, let's wrap up the takeaways here. This whole subword idea got rid of those clumsy fixes. It let models create new words they'd never seen before. And because it focused on common pieces, the models just learned way more efficiently from the data. And here's the really big thing. This technique became a fundamental building block for the massive language models we use every single day now. We're talking everything from Google Translate to the models that power things like ChatGPT. So teaching a machine to see the little pieces inside of words basically unlocked an infinite vocabulary. It was a massive problem solved. But it does make you think, doesn't it? Now that machines have the building blocks of our language, what's the next big hurdle to them actually understanding us? Not just what our words are, but what we truly mean by them.